Read the following stories, then draw a graph that represents what is happening. Be sure to label your axes appropriately for each story. So in a walking experiment, Josephine walked a total distance of 40 feet. At the halfway point, she had walked for 25 seconds. She stopped for 5 seconds to tie her shoe and continued walking for 25 more seconds. Sketch a graph that shows Josephine's distance from the starting point over time. So we'll have time on the x-axis and then distance from start on the y-axis. And I know that she walked a total distance of 40 feet. So I know my y values need to go up to 40. So let's see. If I have, it looks like I can't go by ones. Maybe I can go by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. Yeah. So I'll go by twos and I'll do, let's see, that's 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. No, apparently I counted wrong. 30, 32, 34, 36, 38, and then right here is 40. So I'll just make one more line for 40. And then time, we know that she walked for 25 seconds. She then stopped for 5 seconds to tie her shoe and continued walking for 25 more seconds. So that's 55 seconds. So let's see if we have, this is 0. We need to go up to 55. So let's see, I can't go by, I'll go by 5s, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So that's 10, 20, 30, 40, 50, 60. So at the halfway point, so that means at 20, she had walked for 25 seconds. So at 25 seconds, she had walked halfway to 20. So she starts at 0 and she goes up like that. And then she stopped for 5 seconds to tie her shoe. So between 25 and 30 seconds, she stopped, so her distance is not changing. And then she continued walking for 25 more seconds. So she goes up to 55 and she's at 40. So she goes like that. You're gathering data in the school cafeteria from 8 a.m. to 3 p.m. Sketch a graph that tells a story about the number of cans of soda in a vending machine over time. So here's time. Here's number of sodas. So we don't have anything to scale the y-axis with, so I'll just leave it like that. And our x-axis can be scaled by hours after 8 a.m. So if this is 8 a.m., then we've got 9, 10, 11, 12, 1, 2, 3. So this would be 2 hours after, 4 hours after, 6 hours after, 8 hours after. 2 hours after 8 a.m. would be 10 o'clock. 4 hours would be 12 o'clock. 6 hours after 8 a.m. would be 2 o'clock. And then 8 hours after 8 a.m. would be 4 o'clock. So the number of cans in the soda machine, let's see. Between 8 and 8:30, if let's say they start up here, they're probably going to drop because people might get soda in between 8 and 8:30 before school starts. So let's say they drop. And then for a while until about brunch. So brunch is, it stays the same until around right here, which is brunch. Then it's going to probably drop again during brunch. Then it'll stay the same until lunch at 12, which is right here. And then it'll probably drop again. And then it'll probably stay the same until the end of school. So basically, we just want to see that the soda cans are dropping. The number of soda cans are dropping over time. You are mowing the lawn. As you mow, the amount of grass to be cut decreases. the amount of grass to be cut. You mow at the same rate until about half the grass has been cut. Then you take a break for a while. Then, mowing at the same rate as before, you finish cutting the grass. Sketch a graph that shows how much uncut grass is left. So this will be time, and the y-axis will be uncut grass. We're not going to label any, we're not going to scale it since we don't really have numbers. But let's say we start here with our uncut grass. We mow at the same rate until about half the grass has been cut. So we're mowing at the same rate, so we have a straight line. There, that's about halfway. Then we take a break. So here we're taking a break. Then we mow at the same rate, so we have the same slope until all the grass is cut. Graph each line using the y-intercept and slope. So y equals negative 3x. So this is the slope, and 4 is the y-intercept. So we start at 1, 2, 3, 4 on the y-axis, and we go, slope is the rise over the run, so we go, this is like negative 3 over 1. That's the rise over the run. So we go down 1, 2, 3 over 1. Down 1, 2, 3 over 1. For the second one, 2 is our y-intercept right here. Our slope is 1/2. So we start at 0, 2. And our slope is rise over run. So we go up 1 over 2. Up 1 over 2. Here we're going to start at negative 4, our y-intercept. And our slope is 5 over 1. So we're going to go up 5 and over 1. Up 5 over 1. Again, our y-intercept is negative 4. Our slope is 3. So we go up 1, 2, 3 over 1. Up 1, 2, 3 over 1. That's like 3 over 1. For each line above, write the equation of a line that is parallel to the given one. So parallel means that they never touch, like this. And parallel lines have the same slope. So a line parallel to y equals negative 3x, so the slope is negative 3, so we just need a line with the same slope, negative 3x plus 1. It has a different y-intercept, 1 and 4 are the y-intercepts, but the slopes are the same at negative 3. An example of this one would be y equals 1/2 x minus 3. The slope is the same at 1/2. An example here would be y equals 5x plus 2. The slopes are the same. And here y equals 3x plus 1. The slopes are the same. Complete the table for each rule above. You can use the graph to find the points, or you can plug the values into the equation. I'm going to plug the values into the equation. So if x equals 3, then we plug it in here. So we get negative 3 times 3 plus 4. That's negative 9 plus 4 is negative 5. If we plug in negative 2 times negative 3 is positive 6 plus 4 is 10. 0 would be negative 3 times 0, which is just plus 4 and then 4. 5, negative 3 times 5 is negative 15 plus 4 is negative 11. And here we have y equals 0. So if y is 0, then we get negative 3x plus 4. We'll subtract 4 from both sides. So we get negative 4 equals negative 3x. Divide by negative 3. and we get x equals 4 over 3. For this one, let's see, we'll plug in x equals 1. 1/2 times 1 is 0.5, plus 2 is 2.5. 1/2 times -1 is -0.5, plus 2 is 1.5. 1/2 times 0 is 0, plus 2 is 2. 1/2 times 3 is 1.5, plus 2 is 3.5. We plug in 0 for y, and we get 1/2 x plus 2 equals 0. Subtract 2, -2 equals 1/2 x. Here I'm going to multiply both sides times 2 so that we cancel out the division. So we get that x equals -4. And then the last one, 4 times 3 is 12, minus 4 is 8. -3 times 3 is 9, -9. Minus -9 minus 4 is -13. 2 times 3 is 6, minus 4 is 2. 0 times 3 is 0, minus 4 is 0 times 3 is 0, minus 4 is -4. And then we get 0 equals 3x minus 4. So we'll add 4 to both sides. So we get 4 equals 3x, divide by 3 on both sides, and we get that x equals 4 over 3.